Yadav ji. All of you know that we are conducting online mode of the training program on modern topographic surveying method. Fourth day of this ongoing training program. In last 3 days, we have covered provisions in TOR of the DPR consultant for topographic survey, and one day we have discussed on the DGPS, and yesterday we discussed on auto label surveying. Now for today and tomorrow, we will discuss on total station. In that, Sri Rambir Singh Yadav will cover the basic principle of total station and its features, factors influencing data accuracy collected through this total station, step by step procedure for setting up equipment, recording of observation and data transfer, checklist for handling of equipment, demonstration of field survey, data processing. Uh, uh, so all these things will be covered in these 2 days training program. However, hands-on training will not be covered because hands-on training can only be conducted physically in the IHE. But this is the online mode of training program. But except this demonstration, all the things will be covered by Sri Rambir Singh Yadav. So I request to the participant, please interact with him during his presentation and ask your questions whenever you have any arises any doubts or anything. Please clear your doubts. Today also there will be a 15-minute time break at around 11:15 to 11:30. At the end of the 2 days presentation and tomorrow presentation, participant can also ask the question. However, during the presentation also, participant can also ask the questions. So now I request Sri Rambir Singh Yadav sir to start his presentation as well as his experience with the participant. Thank you.
Thank you, sir. Good morning, all of you.
Good morning, sir.
Sir, how many are joined? We have to wait for 5 minutes to join all of you. Yeah, we can start.
That we can start now. 37 have joined so far. So I think within 1 or 2 minutes remaining who want to attend, they can also attend. So
okay, total how many participants?
actually nominations we have received about more than 100, but generally we are seeing that about 70 person are joining.
Okay, no issue. Okay, my screen is visible to all?
Yes, sir.
Okay. My name is Rambir Singh Yadav. I'm General Manager and I'm Technical Head of all over India of Topcon Instruments. I was in the Indian Navy around 15 years. After that, I have taken the short retirement. And then in 2001, I was joined Nikon. Nikon is the survey instruments division. So they are manufacturing total session, theodolite, level, survey instruments. But later on, I have shifted to Topcon after 10 to 12 years. So now I am in the Topcon and I'm the technical head, and I'm looking after all technical issue all over India. In between, we have done many projects, major projects, DPR, topography, and everything. The major project is our mainly Delhi to Chennai and Calcutta to Mumbai, 4,400 kilometer DFC corridor that is done within the 9 months, and it is very difficult to do within 9 months. Uh, 4,400 kilometer topography and control points. So we have done it, and apart from this 4,400 kilometer, we have done 110 kilometer Agartala to Sabroom project, Bhairvi to Sarang 70 kilometer, 90 kilometer Dimapur to Kohima project. So many hilly terrain, all are the hilly terrain projects. So we have done many projects. Before 2006, nobody is using in India GPS. Everybody is using only toll session and level, theodolite. So everybody says that GPS data and TS data is not matching uh, in the field. Means error is coming in the field uh, roughly 2 to 5 meters, or sometime it is 8 to 9 meters. So they have abolished GPS data and they are using normally toll session data. But when I because I am using in the Indian Navy, I am using both system, GPS also and TS also. But in civil, nobody is using. Every department is saying no, no, this data is not matching. This data is not matching. So I have a challenge because I am the technical head of the Topcon Nikon gimbal. So I have the challenge that it should be meet. GPS data and T data should meet. So we have given many presentations, but our department is saying no, it is in the field. Okay, on the paper it's okay, but in the field it is not matching. GPS data and TS data is not matching. So I say okay, no problem. We will show in the field also. So one rights department in is there in Gurgaon. They say okay, if you want, you can give the demo. Practically, we want to see around 11-kilometer stretch to meet with the GPS and TS. So I'm thinking that they will allow in maybe in the plain area, but they say no, we want in the hilly terrain. So they have taken us to the tunnel of the Kajikuntu Banihal project. That is 11-kilometer project. So we have done our GPS control point. Then we have run a traverse. The data is matching within the millimeter or centimeter. So they are very happy. They say, okay, this if you will use this type of technology and techniques, we can meet the GPS and TS data will meet each other. Then they have allotted this major project, Calcutta to Mumbai and Delhi to Chennai, Bhairvi to Sarang. These all four projects they have allotted to us, and we have completed within the time schedule, and we have submitted the data. After that, we have done many projects, small projects. These are the four major projects I have explained you. Then maybe in the 2013, I am worried that in India everybody is using only for horizontal control GPS point. Nobody is using GPS for vertical control point. So we have done a big project, 350-kilometer project, Bhagapur Khurja. That is the railway project. So we have done the vertical control also with the help of the GPS. Then we have explained the if you use this type of technology, and this is the technique, if you use, you will get the vertical control also be done by the GPS. Then in 2014, one project has came, that is Mumbai to Ahmedabad, 500-kilometer project DPR is required within 1 month. So it is possible only by the GPS only. So right says if you can do, you can help us, then we can complete this project within the 1 month. So I have explained them that we have done a practical 350-kilometer vertical control by GPS. So we can control this vertical control by the GPS only. So we can finish in 1 month DPR. So they have allowed us, and we have done that 500-kilometer also with the GPS, TS, and auto level. Everything is combined, and then it is a hybrid survey. So okay, no issue. You have maybe learned the GPS level. Today is the toll session. What is the principle of toll session? I will explain you. Survey. First, I will explain you the survey. Survey is the science and art of determining the relative position of point above or on beneath of the earth surface and locating the point in the field. Means from relation one point to another point, we have some relation distance between one point to another point. Relative position. If I assume this is the 100, the next point will be with respect to 100. If I assume this is the north, with respect to this north, I will get the next point. So this is the survey of the project. If you have done good control point, good topography, your project will be go smooth. If something is mistake in your control point and your topography, your project will be always delayed, because if you have not done proper control point, so your alignment will be changed. And if alignment is changed, the land acquisition will be required to be changed. Cutting of tree is required to be changed. Electrical uh, line to be changed place to another. So many things will be delayed in the project. So if you have done a good control point, your alignment will go smooth. If you have done a good topography in the field, good topography means you have collected each and every field of factor. So you have to change the alignment. You have to reroute the road. So this way, if you have done a good topography, good topography means you have collected each and everything from the ground. Your design will be very perfect. So your project will be go smooth. And the category of survey, there are different. One is a geodetic survey. Normally, while is equal to 1.8, roughly 1.8 kilometer. So roughly it is around 20 kilometer. We assume this earth is plane. We can do the plane survey. But if we are going more than 20 kilometer in one step, then we will do the survey. It is required to correct the earth curvature, T minus T correction like that, and we will get the good result. Because geodetic survey we will do one country to another country and kilometer, and in the hill area we do normally 1 kilometer or 2 kilometer. Even when we are doing the metro, we'll do the 1 kilometer control point. So if we do the one kilometer, that means 1 kilometer plane, or if we'll do the 5 kilometer, means 5 kilometer is the plane. So one point to another point we close the traverse, and then next point to next point we close the traverse. So T minus T correction is not required for the plane survey, but geodetic survey T minus T correction is required. Survey method, there are few survey methods. That is that one is the photogrammetry. Photogrammetry means we have to take the photograph from two different direction. Both photographs are overlap to each other, then you will get the 3D impact of your area. So means you will get the 3D picture. 3D picture means you will get the X, Y and elevation. When both images overlap by the 60 degree. This function is come from the human eye, because human eye has a two eye. If you see through one eye, you will not get the 3D picture. But if you will see both eye, then you will get the 3D picture, because one I will be take one photograph, second I will take second photograph, and both will overlap to each other more than 3D. Same way in photogrammetry, in earlier days we are taking the photograph from the aeroplane and then overlap it and then make the drawing. But nowadays we are taking these from the satellite. So we are taking the image from the satellite, second image from different direction. Both are overlap, then we will get the 3D position. So this is called photogrammetry. We are taking the photographs. Next is the boundary survey. This boundary survey normally to collect the boundary point of each property holder. Means like when we are doing the topography, when we are doing the DPR, so we have to collect all boundary point of each owner. So we will get the area of that. Like if I'll collect the 7 point of IHE, we will get the area of IHE. That this much area of IHE is having. And in boundary survey, it is not everything. Only corner of boundary is required to collect. So when we are going for acquire the land, we can understand, okay, this much land is available for A, this much land is available for B. So we can acquire from A 5 acre, and for B 20 acre. Like that we can acquire the land. For boundary survey is normally required for land survey, acquiring of land purpose only. Next is the control survey. Control survey normally we have to do the control survey before DPR. So when we have complete the control survey, you will get the horizontal control and vertical control both. So horizontal control is for the alignment. The alignment should not move to the left and right, and vertical control is up and down. So designer can design as per the your topography. So topography can be done when the horizontal control is good. If your horizontal control is not good, means not accurate, it is in the decimeter, centimeter or meters error. So maybe when you are collecting the building, it go 1 meter left or 1 meter right. So designer is not able to design properly. Same way, when you are doing for, this is the for DPR, when you are going for construction, that time if your horizontal control point is not correct, so your center line will be not marked accurately. From one control point, it will come at one place. From second control point, it will come in different place. So your line, if it is not matching, you are not able to construct proper your pillar or some even soil filling. It is not done by properly because your control point is not correct. So in the project, control point is very important. In control point survey, we do with the DGPS, with the toll session, with the level. DGPS and toll session, we can do the horizontal control point. Like with the DGPS, we will fix up every 5 kilometer pair of control point in the ground. After that, we have fixed up the pair of two control point in 5 kilometer. We will run a traverse between these 5 kilometer. From two control point to next control point, we run a traverse and close to the next control point. So this is called a closed traverse. Means there are two type of traverse. One, you start from the known and go up to 5 kilometer and reverse 5 kilometer and close to the same point. This is also called a closed traverse, because we don't have control point after 5 kilometer. So we have to run back and close to the same point. So if it is come in the say your required accuracy, then it means your traverse is correct. If your traverse is correct, so you will get the horizontal control point. So your control point every 250 meter, 200 or 250 meter, your control point is very accurate, and you can use these control point in the field to do the topography, to mark the center line, or to construct your project. So this is a horizontal control. Second is the from the two non-control point, you can start the traverse and close to the next after 5 kilometer next two control point. If it is meet in the accuracy, then it means your traverse is correct. No need to run back to the first point, zero channels. You have started from zero channels, go up to 5 kilometer channels. If you have a 5 kilometer channels to control point, you can close the traverse on those 2 points. And if it is your bearing and distance is matching as per your required accuracy, it means your traverse is correct. You can adjust that error in between those points, and you can finalize those control point as a permanent control point, horizontal control point. Same way vertical control point, you can run from that first TBM every 500 meter you have mark a TBM, temporary benchmark. So first benchmark you can start leveling 1 kilometer, run back. If it is closing within 2 mm, it means your level is correct, and your in between control vertical control point is very accurate. With respect to this vertical control point, you can do the cutting, filling, whatever work you want to do. You can, with respect to the RL, you can use this vertical control point. So you have to make the monuments for this horizontal and vertical control point. Monuments means pillar. You have to make a pillar on the ground and run the traverse on those pillar, and run the vertical level on those pillar. Then your control point is finally your after adjustmenting this control point. Finally, these are your control point. You can use for the topography, use for the construction purpose. So this is your control survey. Next is the engineering survey. In the engineering survey, normally when we are doing the engineering project, we have main interest of our civil engineering, that we require position XY. Where is our XY? Where is our XY? What, like if you want to make a pillar here, so we want the center of the pillar. So we have to mark with the tool station, this is my center of the pillar. Then how much it is constructed? Elevation. As per the elevation, you can define the elevation. So in the civil survey, engineering survey, we give the point, provide the point elevation to building civil engineering project. Next is the topography survey. In topography survey, because first we have done a control point every 200 meter. With respect to this 200 meter, we have to collect each and everything. Like we have defined a corridor. As per our requirement, like we have a corridor of 40 meter, we have a corridor of 50 meter, we have a corridor of 100 meter. So we have decide first how much width of our road. As per that, you have to take more area to collect the topography, so designer can design easily. From this way our road can go. For that area is defined that like 50 meter corridor we are going to pick up for this road. So that, or somewhere it is 100 meter, somewhere it is 80 meter, depend upon the road size. 4 line, 2 line, like that. So you have to collect that width, each and everything, like tree, building, electrical pole, main manhole, river, whatever things is coming in between that corridor, you have to collect each and everything. So that field can be represent on the computer, on the map, that this is the how much tree, and it should be collect in the different layer. So like in the AutoCAD, when you import this data, it will come in the different layer. In that layer, like if we want only tree to see on the map, so we can switch off all layer, only tree layer should be on. So in that case, we can understand, okay, this is the 1200 tree we have to collect. trees in our area. So we can give that map to the forest department that we want cutting of these 1200 trees. Same way, like high tension line is going. So we have a code of high tension line. We have a different layer of high tension line. So we can switch off all layer, only high tension line will be there, layer will be on. So we can submit this drawing to the electrical department that we want to shift this high tension line from this place to that place. So if you have collected the topography correctly, like if you have not collected the high tension line, so as per the designer, no high tension line in your project, so no shifting is required. But when you are going in the field, high tension line is there, high tension line shifting is required. So in that case, we have to run again file to the electrical department, and maybe some project can be delayed. So this way, if you do perfectly topography, each and everything features, like when you are doing the topography, the instrument will ask first point name, then it will measure means it will collect the horizontal angle, vertical angle, slope distance, then calculate each and everything, and it will record in the memory x, y, and elevation also, z also of each and every point. Then when you recording the point, he will ask what is this, like it is a tree, it is a building, it is electrical pole. So you have to write the code in front of that point number, and then it instrument will ask in which layer you want this code. Like if it is a tree, so you want if you want this tree to be saved in the vegetation layer, so it will save in the vegetation layer. So whenever you switch off all layer, only vegetation layer is on, then only tree can be seen. Same way, manhole, uh, culvert, whatever thing. Or if you want the only, if you don't have any structure or man-made features, you can collect the GL, ground level. So this ground level can be used for the making the DTM, terrain of your model. Data terrain of your model means contour you can make. Okay, how much, because with respect to this contour we can get how much cutting and filling is required. So if you don't have the any man-made features or natural features, then you have to collect in the ground, that is GL, ground level. With respect to this ground level, we make the contour, we make the volume calculation. Next is the route survey. In the route survey, same it is a topography survey. Topography survey is the command survey, you can collect. But in route survey, we have defined the route. Like in the road survey, railway survey, we do the route survey. Topography whole we have to do the topography. But in route survey also we are doing the topography. But we have limited width. Like it is a 40 meter, 80 meter, 100 meter, 200 meter, whatever we have defined that this much corridor we have to do. So in the route survey, we are doing longitude. It may be 100 kilometer, it may be 500 kilometer, it may be 1000 kilometer, it may be 2000 kilometer. It is a longitude. But in the route survey, the vertical control should be very accurate. If you have a, like if you have a route of 500 kilometer, if your vertical is control, then your line will be go smooth. Like from Ahmedabad to Mumbai you are going, so you will reach at Mumbai perfectly. But if your alignment horizontal change, you will not reach the Mumbai, you will reach to the Pune. So your in the route survey, horizontal control should be very correct. It is a project, we have to define the route, that is this route we have to go and complete the survey. In the pipeline, road, transmission line, we do the route survey only. Next is the hydrography survey. In hydrography survey, we measure the depth of the water body. How much is the depth? Like when we are doing our project, in our case, we do only hydrography in the river area. Whatever river is coming in between our project, we have to survey that river. Like 2 kilometer, 1 kilometer downside, to get the flooding estimate, that how much flood will become, maximum flood, highest water line. So this type of hydrography survey we do. normally we do in the hydrography survey depth of your river. So you can get like depth is 5 meter, so we have to construct 5 meter pile in this river. Yeah, 10 meter depth, 10 meter pile should be constructed in this river. So this is the bathymetric survey, means each and everything we have to collect from the river. Next is the astronomical survey. Astronomical survey normally in older days we are doing. Nowadays we are not doing because we have a GPS, so we do the control point with the DGPS. In olden days we normally do because we don't have the GPS, so we do the observation of sun observation or star observation. Like in the early in the morning, we get up and set up the theodolite, and we have a almanac that okay, at this much time sun will rise in this direction. So we know the angle also. Okay, at Delhi sun will rise at 90 degree 12 minute 15 second. So we want to observe in the daily, so we have to fix up first one pillar on the ground, two pillar, one where we have kept the theodolite, second where we have kept the prism. So those two control point we have fixed the pillar first, then we set up the theodolite there and see the early in the morning sun where is rising and set the horizontal circle to the 90 degree 12 minute and 15 second. So hold that angle and sight the sun. When because sight the sun means sun never be see by the optics, because this optics is the 30 time or 28 time magnifying. If you magnify 3x magnification with the sun, your paper can be burned. In 10th class we have studied in the science subject. But if you magnifying that sun rays into 28 time 30 time, it means your retina will be burned. So never ever see the sun through your telescope. When you are seeing the sun observation, you should have a filter in front of a objective glass, and different type eyepiece will become, so you have to fit that eyepiece, because normal eyepiece will have a cross wire, but in the sun observation eyepiece will have a four quadrant. In all quadrant you will see all object. Like when you see the sun, you will see the four sun. One is first quadrant, second is second quadrant, third in third quadrant, and fourth is fourth quadrant. So when these fourth, all four sun seen and crosshair wire in the center of these all four sun, then means it is the center of your sun. Then you release that angle and observe the next pillar. Your bearing will be this much bearing of first point to second point. Same way we do the star observation. At the night we do the observe the north pole. We north pole when we will observe, then set the horizontal angle 0 0 and release the angle after observing the north pole, and then read the next pillar. You will get the bearing, exact bearing from the north. But on those days what we do, we start observe the north pole or sun, then we do the every 250 traverse, and after 5 kilometer we read again at the night north pole, north star observation, or in the morning sun observation. We whatever we have started from 0 and go up to 5 kilometer, see what bearing is coming, and when measuring the star observation or sun observation, what bearing is coming. If it is difference in the seconds, means in the limit, we adjust these 5 kilometer. If it is not come, then we have to run again traverse, because now we have a fixed bearing. In zero channel also we have observed the star, in 5 kilometer also we have observed the star. So we have the fixed bearing of both. So when we are going from 0 channels to 5 kilometer, this bearing should meet. If it is not meeting, it means it has a error. If it is error or in the limit, then means you can adjust this angle in between. If it is not in the limit, you have to run again traverse. So these are the survey method normally we use in the field for collecting the topographies. The horizontal accuracy in the survey. In static survey by DGPS, accuracy can be achieved by 5 mm plus 0.5 ppm into base length. In traverse survey by total session, accuracy can be achieved by 2 mm plus 2 ppm by 1 second total session instrument. Uh, Maybe GPS, I need not to explain because it is a distance error. So my like 5 kilometer, you have a two control point at 0 and two control point at 5 kilometer. It means the distance between these four control point is 5 kilometer. So the accuracy in the DGPS we achieve 5 mm plus 0.5 ppm. Like 1 kilometer it is 5.5 mm. After 2 kilometer it is a 1 mm. 3 kilometer 1.5 mm. So it is a 5 kilometer. Maximum error can be 7.5 mm. So your DGPS is more accurate. But in total session, your accuracy will be, because in total session there are two type of instrument. One is the EDM, second is the theodolite. EDM accuracy is different, theodolite is different, accuracy is different. So in EDM, electronic distance measuring unit accuracy is 2 mm plus 2 ppm. Yani 2 mm is the constant value, centering error, labeling error, mechanical error of the instrument. So 2 mm is the constant of the EDM. And 2 ppm is 2 part per million, 2 mm per kilometer. So if you are measuring a distance of 1 kilometer with the total session, your distance may be 4 mm plus or 4 mm minus, maximum error. But if you are measuring the distance 500 meter, so 3 mm, because 2 ppm become half 1 mm. So it will become 3 mm plus or 3 mm minus. If you are measuring the distance of 250 mm, so it means your accuracy may be 2.5 mm plus or 2.5 mm minus. This is the EDM accuracy. But second instrument is required, theodolite. So theodolite has a angular accuracy. In third session, there are 4 5 models. One is the 1 second total session, 2 second total session, 3 second total session, 5 second total session, 7 second total session. If you have a 1 second total session, means the accuracy of your theodolite is 1 second. If you measure with the theodolite, this is the 0, then you rotate into 180 degree, it should come 180 degree 00 minute or 1 second or 179 degree 59 minute or 59 second. It means 1 second plus or 1 second minus. It means your instrument is 1 second accuracy. So if you do with that 2 second rotation, you when you fix to 0 and rotate to 180 degree, it may come 179 degree 59 minute 58 second, or 180 degree 0 minute 00 minute or 02 second. It means it is a 2 second instrument. So likewise, if it is a 1 second instrument, the error will go up to maximum 4 mm in 1 kilometer distance. Angle is moving. Same way, if it is 2 kilometer, it is 8 mm. So normally in the control point survey, we do with the 1 second total session. So your instrumental error will be nullify at least 1 kilometer. But topography survey, we use normally 5 second total session, because in the topography we have a every 250 kilometer or 200 meter control point. So when we are going for topography, we are using these two control point, not from the zero channel, is not coming from zero channel. We are just going directly to CP10 or CP11, because this CP10 and CP11 is the in between control point of GPS 1 and 2, GPS 3 and 4. So we have to collect the topography of CP 10 and 11. We will not go to GPS 1 and 2 or GPS 4 and 5, 3 and 4. We directly go to CP 9 and 10 and 11. We set up because 10 and 11 is the accurate coordinate. We have just run a traverse, and after running the traverse, these control point arrived. So we use this control point 10 and 11 and then do the topography. When we are doing the topography, if some 5-second error is there, it means your angular error is 5 seconds, but we are measuring maximum 200 meter, 300 meter. We are not doing accumulate error in the topography. If tree is here, in place of here it is showing 5 mm this side, 5 mm that side, doesn't matter because accumulate error is not there. In traverse, it is accumulate control point. If you and we have second time kinematic. Whatever error your base to the air, and rover will correct ground truthing points. So if ground truthing means you have a control point, every 1 kilometer you have a control point. Whenever you are doing image rectification, you have control point, you assign that control point value, your all image will be correct. Same way in the mobile mapper, you should have a control point. When mobile mapper has collected the data, you can define that control point value, your accuracy will be 20 to 30 mm. Same way आपका scanner, when you scan the area, if you have a control point, you can use those control point. Your accuracy can be achieved 5 to 10 mm. So vertical accuracy in the survey, static survey by DGPS instrument can be achieved 5 mm plus 5 mm plus 1 ppm into base length. Means in the horizontal control it is a 7.5 mm, but vertical control it is a 10 mm in 5 kilometer. But for vertical control, you should run at least 4 to 6 hour observation. Horizontal control, 1 hour observation, static observation is sufficient, but vertical control at least 4 to 6 hour required for the vertical control. For fly leveling, by the auto level or digital level, the accuracy can be achieved by 2 mm or better as per requirement or instrument. Like if your instrument is having 2 mm accuracy, you will get the 2 mm accuracy. If your instrument is having 0.7 mm accuracy, you will get the 0.7 mm accuracy. So it is depend upon your instruments. Finalize the alignment. How to do the finalize the alignment? Like we want to this is my highway, and we start the from this highway. Our startup point is this, and our road and here. So we have just mark on the Google Earth. This is my alignment. On this alignment, we want to construct a road. For that purpose, we have just roughly aligned this on the Google. Then we can recce this on the ground. Then we make a control point like GPS control point every 5 kilometer, like 0 channel is 1 2, 5 kilometer channel 3 4, 10 kilometer 5 6, and 15 kilometer 7 and 8. Likewise, we can design the horizontal control point. When we have designed this horizontal control point, then we can do the planning how to do the horizontal control, because if we have two type of frog method and triangulation method. So we run with the triangulation method. 1 2 GPS, this is a temporary point. So we make this triangle 3 4 1 2 and T point, then T1 to T2 this triangle, then 5 6 to T2 this triangulation, then T2 to 5 6 T2 T3, then T3 to 7 8 and 5 6. If you make this triangle, your alignment will not move left right, because this will not allow this person to go out and go in. So your horizontal control is very accurate. With respect to these control point, now we run the traverse in between these point by with the help of total session. So we run that, these are the traverse point. This is the GPS point. 1 to TS 10 and 12. This is the 5 kilometer. So in between we run the TS1, TS2, TS3, TS4. This is the traverse point up to traverse 11. Then close here. Then from here again start this point, GPS 1 and 2. We can TS 13, 14. We close to the GPS 4 and 5. This way 1 2 3 4 5 6, we can just go one by one traverse with the total session. Now we have a TS2 TS3 is control point on the ground. We mark something on the, likewise here is a bridge. In between this TS2 to TS3 is a bridge. So we can use these two control point, and we can mark the center line of your bridge or the center line of your road. Surveying instrument. There are few survey instruments we are using in the field. In olden days, we are using chain. Chain is for distance, because on those days we don't have the electronic distance measuring unit. So we normally measure the distance with the help of the chain. Then auto level for leveling purpose. Theodolite for angle measurement. ADM for distance measurement. Next generation is came theodolite total session. fluorescent for measuring the angle, distance. Next is the GPS, global positioning system. Next, drone, image, and mobile mapper, scanner. Many instruments are there. So in olden days, we normally use this chain. We use the instrument is chain, field book, and mapping. Plane table we do on the plane table. This type of chain is there. We have to measure the distance with the help of this chain. These are the level, dumpy level. These are the auto level. Maybe you have already seen yesterday. I'll escape this auto level, no issue. This is for what benchmark to permanent benchmark, temporary benchmark. Leveling can be done by the auto level, digital level, or this benchmark can be shifted from one place to another place and then run back the digital level. These are the benchmarks. Next is a theodolite. In olden days, we have a theodolite, that is physically we have to read. This is the horizontal circle. So we have to read the horizontal circle, and this is the vertical circle. We have to read the vertical circle. So we have to write horizontal angle is this and vertical angle is this in those days, 1 year theodolite. Next come to the optical theodolite. Optical theodolite means this graduation is inside now. Horizontal and vertical graduation is inside. We can see through optics. What is the this the through the optics we see angle, degree, minute, and second. So with the, because the naked eye in 1 year theodolite we see through the naked eye, no magnification. But in this optical theodolite we have a magnifying because we have a eyepiece. So we see through eyepiece. Instrument has the eyepiece. With this eyepiece we see angle, degree, minute, second. So we can achieve more accuracy in this optical theodolite. Later stage we have developed the digital theodolite. Means no need to read the circle reading or no need to read through optics. Previously we are seeing through the manual naked eye, then through the optics, but in digital theodolite we see directly horizontal angle and vertical angle on the display itself. It is displayed the horizontal angle. When we move the horizontally it will show the horizontal angle. When we move the vertical it show the vertical angle. But till date we normally use theodolite only for angle measurement. Distance can be measured by using the staff reading. Top reading is 100 by 100 we get the distance, but more distance is not possible to measure. So we have a EDM technology those days. In this olden days we have the EDM MRA5 MRA7 system. In those EDM first we have to set up on the tripod theodolite to measure the angle. Then we remove the theodolite and set up the EDM MRA5 MRA7. We measure the distance with the help of this measuring unit. So we have to set up two time instrument. One is the theodolite to measure angle. Second time we have to set up the EDM EDM to measure the distance. Then calculation is required to be done. And next is they say okay, no need to set up the MRA5. We have a EDM on top of the theodolite. So in that case, your both rays are going to the same point and reflect from the prism, and he will get the angle, also get the distance from the. So on those days, we normally measure up to the for the single prism, we can measure up to the 1 kilometer. If we increase the prism, three prism means the surface is increased. So EDM rays can because this EDM rays on those days we are using microwaves and infrared rays. Those starting from the EDM, it's going out like that. So up to 1 kilometer, single prism range can be done. But after that, the width will be more. So we required more prism. means 3 prism we fit, so we can measure up to 1.2 kilometer. If we set up 5 prism, up to 1.4 kilometer. If we set up 9 prism, 1.6 kilometer. So we used to increase up to 11 prism. Maximum distance we can get 2 kilometer with the help of 11 prism. But so next technology means these are the EDM. Separate EDM is not popular nowadays because it is fitted in the total session EDM. So we normally use the total session EDM, built-in EDM. On olden days, we have a different EDM. This is the different. Then this is also different. But nowadays, it is come with the help in the total session itself. They have fitted the in the total session. So this olden days normally microwaves and infrared. Nowadays we have a laser base. So in this olden days, this frequency distance is very less. But nowadays we have a laser base. With the laser base, we can measure with the single prism 2 to 5 kilometer. And because it is a laser is going and reflecting back. So up to 500 meter, no prism is required. We can measure without prism also, reflectorless. Means each and everything is whatever you are seeing, it means some light is reflecting from that place. If I'm seeing this is my pen drive, it means some light is going to the pen drive and seeing my mind is concentrating that this is the pen drive. Okay. So same way, if a laser is going and hitting to any surface, it will reflect back. If it is a wet surface, the distance is less. If it is a dry surface and reflecting 90%, you will get the distance up to 500 meter. It depend upon the model to model. 300 meter to 1 kilometer also, 200 2 kilometer also you can measure without prism. But normally we recommend that up to 200 meter can be measured with the reflectless mode, because after 200 meter your naked eye is not able to see. If your naked eye is not able to see, it means something in between is coming. Like we are measuring that wall, but in between some leaves of the tree is coming or some tree is there, you are not able to see by the naked eye 300 meter 400 meter. So through the optics you are focused only that wall. So you are thinking that we are getting the wall coordinate. No, in between some tree leaves are there 300 meter. So this laser will touch these leaves and come back. Means you will get the coordinate of 300 meter, not 500 meter. So recommendation is up to 200 meter you can see through the naked eye that nothing is in between. So you can measure the reflectors mode up to 200 meter. In where the man is not able to go and we are not able to fix up the TS nearby 200 meter 300 meter, then we can measure 500 meter also, 1 kilometer also, 2 kilometer also. Like we have a Chinab bridge project in the J&K. Khori to Bakkal is the 1 kilometer distance, but in between is the river. So it is not possible to measure from Khori to Bakkal, Bakkal to Khori. So we use that time we have used the 2 kilometer reflectless total session, because when we claim it is a 1 kilometer rotation, we can measure in the field 500 meter, because surface is not perfectly giving back 100% reflection. Maybe some observer rays. So it is maybe 90%, 19%, 20%, 30%. So distance will. So we have used in that project 2 kilometer total session reflectors mode. So we have achieved 1 kilometer easily. So in the EDM, depend upon your accuracy and your requirement, you can use the total. But the field normal topography survey, we normally use 200 meter with the reflectless mode. So this is the total session. This total session is the combination of your theodolite. This is the theodolite. No separate idiom. They have fitted the idiom inside the telescope itself. So wherever you are sighting, nowadays the idiom is heating. In olden days, what happened that you are sighting with the theodolite, but idiom is will be there. So it will not hit that same prism. If not hitting that same prism, then you will not get the distance. You are sighting through the theodolite correctly prism, but idiom is not going to that center. So you are not getting the distance. In nowadays, the projection will have the idiom fitted inside the telescope. So wherever your telescope is seen, idiom will go there only, and you will get the distance easily. So this is the telescope and idiom fitted in the telescope. This is the locking screw. This is the tangent screw, vertical movement. Same way, locking screw and tangent screw for horizontal movement. So these are the parts of the horizontal angle: locking screw, tangent screw for horizontal angle, vertical locking screw, tangent screw for vertical angle. This is the battery case. We can fit battery. This is a display. This is the open this cover. You can insert this pen drive, or you can insert the mini USB cable. So you can download through the cable, through the pen drive. This is the handle. This is Bluetooth, eyepiece, focusing knob. Eyepiece is to clear the crosshair wire, and drum is to focus your prism. If distance is less, you have to move left. If distance is more, you have to move right and clear your prism. So down is this is the have keypads, and this is the there are two type of toll session. One is the DOS base, second is the window base. So if it is a DOS base, this the normal angle distance like this. No touch can be work. Only DOS. You have to give all commands through the keys only. Measure, record, code, everything you have to feed with the keys only. If you have window base, you can feed with the keys also, as well as with the, because it is a window base means touch screen. So you can rod, if you ask them the raw data, they will work 100% in the field. Otherwise, they will collect 25% from the field. Rest 75 points can be manipulated in the computer. So, but raw data is only 25%. If he has collected 25% from the ground and 75% he has manipulated on the computer, 75 points on the computer manipulation, that 75% data, raw data is not available. If you have asked raw data, So you will get 250 is the raw data and thousands point in your drawing. It means he has not done proper survey. He has collect only 25% from the ground, 75% he has manipulate in the AutoCAD only. So whenever you are offloading the work, please ask them we want raw data. Raw data is the horizontal angle, vertical angle, and slope distance. These raw data is measured by the tool station on the ground itself. When you are moving horizontally, it will measure the horizontal angle. When you are moving the vertically, it will measure the vertical angle. When you are pressing the measure button, the EDM will distance will go and come back. You will get the distance from tool station to prism. So these are three raw data. Rest everything is calculated from the horizontal angle. Like you have a two control point, one A, one B. You have bearing because you have coordinate of A and B. So delta northing, delta easting, you can calculate the bearing from A to B. So instrument will calculate automatically bearing A to B. When you measure the horizontal angle 10 degree, example. So back bearing is 220 degree and you have measured the 10 degree horizontal angle. So your next point, C point bearing will be 230 degree because 220 is the back bearing, 10 degree is the horizontal angle. So your bearing will be 230 degree. Now you have a bearing from A to C. You have calculated the bearing AZ from A to C is the 230 degree. Now you have measure the horizontal so slope distance and vertical angle. With respect to the slope distance, you have vertical angle. He will calculate because vertical angle tan theta you will get the vertical distance. Now you have a slope distance and vertical distance in this triangle. Now you have one angle, one distance, one this distance also. So this is the 90 degree. So you can calculate this third angle also. Now you have a three angle in triangle and two distance. You can A upon sin A, B upon sin A. He will calculate the horizontal distance. Now you have a horizontal distance. With respect to this horizontal distance, you have bearing of 230 degree. Sine of bearing multiplied by horizontal distance, that is delta northing. Sine and cos multiplied by the horizontal distance, you will get the delta easting and delta northing. Now, with respect to this bearing, with respect to the slope distance and vertical angle, you have calculated the vertical distance. You have collected the horizontal distance also. So you have calculated horizontal distance, vertical distance with respect to slope distance and vertical angle. So bearing also calculated, horizontal distance also calculated, vertical distance is also calculated. Now with respect to this bearing and horizontal distance, we will calculate the delta easting and delta northing. With respect to this vertical distance, we can add or minus this vertical distance from the RL of the instrument. You will get directly Z value of that point. Same way, with respect to this delta easting, delta northing, you can add or subtract to the total station point XY, you will get the C point XY. So now you get the X, Y and Z. This is the method to calculate the X, Y, Z of next point. So whenever you press the measure button, TS will measure the three things. One is horizontal angle, one is vertical angle, one is the slope distance. These three things are the raw data. Rest six parameter he will calculate: vertical distance, horizontal distance, bearing. With respect to this horizontal distance, bearing and vertical distance, he will calculate the northing, easting and elevation. So this way he will collect nine parameters. Three is the raw data, six is the calculated data. Then if you give a command save, so he will give the next number like five number. One number A, two number is B, three C, four D, five is the E. So next number is the five. So he will record in the memory five number. coordinate xyz, and now he will ask code of that point. Then you can give the code: electrical pole, tree, building. So this way he will collect, record in the memory. Now he has a total 11 things in one point. One is horizontal angle, vertical angle, slope distance, bearing, vertical distance, horizontal distance. Sorry, first is horizontal angle, vertical angle, slope distance, horizontal distance, bearing, northing, easting, elevation, point number, and code. So total 9 parameter will be saved in the memory. And next point, 6 number is ready to collect. And also you can define if you have a window based processor, you can define the layer, so it will save, same code will save in the same layer. You have to define once in this total session. You have to define once. It is a electrical pole, EP. So next time whenever you are giving EP code, it will go automatically electric layer, because EP you have given electric layer. So whenever you are giving code EP, that point number, it may be 5 number, it may be 25 number, it may be 35 number, it may be 67 number. Whatever number is this serial number, whenever you are giving code EP, it will go directly to the electric layer. If tree is coming, your tree number is 7, 9, 13, 18, whatever number is. But whenever you are giving code tree, it will go directly vegetation layer. So it depend upon building BLD1, BLD2, BLD3, whatever code you are giving building 1. So whenever you are collecting the building corner 1, point number may be 7, 17, 27, whatever that point number, but code is same: building 1, building 1, building 1. It will go to the building layer. So this is the function of the normally window based processor, that you can store this data in different layer with the 11 parameters in the memory. So likewise, you can record lakhs of point in this instrument, because this instrument your instrument memory is 500 MB, some 500 MB, some 1 GB MB, 1 GB memory. So these 1 MB can record more than lakhs point. So you can store many lakhs points, and later stage you can download these data through the pen drive or through the cable to the computer, and you can empty the memory of your processor. So this way you can work in the field. Shall we have tea break?
जी सर.
Okay, what time will all will join?
सर 11:30 सर.
Okay, okay, Neeraj. We will have a tea break, then we can continue. वीडियो भी ऑन करना पड़ेगा ना. Okay. Before tea break, we have seen that total session is giving us the horizontal angle, vertical angle, slope distance. These are the three raw data. Rest everything it is calculated. Horizontal distance, vertical distance, bearing, delta easting, delta northing, delta VD. And then this delta northing, delta easting, delta VD plus or minus in the instrument position, we will get directly northing, easting, and Z of next previous point. So the total session, because when it's measure horizontal angle, vertical angle, it function as a theodolite. When it measure the distance, it work as a EDM. When it calculate this data, because sine, cos, and tan theta, so it function as a scientific calculator. And then it is recorded in the memory, it function as a computer. So it is a combination of all theodolite, EDM, scientific calculator, and computer. All four things becomes one. That is become a total station. So it is a total means theodolite is not required, EDM is not required, scientific calculator is not required, and computer is not required. Everything can be done by the one instrument. That is called total station. So total solution of surveying work, all survey work can be done by the total session. Most accurate and user friendly means the accuracy is very much high. It's measured in 1 second angularly and 2 mm plus 2 ppm ADM. Then it is a directly give the position northing, easting, and Z with respect to the base point where the instrument is there. With respect to that, he will give you directly northing, easting, Z. No need to calculate everything. On older days, we are calculating because we don't have that time theodolite scientific calculator also. We have only theodolite and separate EDM. So in that case, we required a logarithm book to get the sine, cos, tan theta. From that book, okay, from this sign, this much value, cos this much value, tan theta, this much value. For that, multiply to the horizontal distance, we get the data north. Then we add this, then we can make on the graphs. So many work can be done in the office. If we have calculated data from the field for 2 hours, we required minimum 4 hours to calculate those data in the office. But nowadays, we just press the measure button within a 1 second, it will directly show you the northern jet and plot in the map. In your screen itself, it plot. So your work is very fast. Directly, he will give you northern easting jet. EDM is fitted inside the telescope, so the collimation error, line of sight error will be finished almost. Digitally display, everything will be displayed digitally on the screen. Topography survey by non-coordinate, like we have two control point like CP9 and CP10. With respect to this control point, we want to do the survey. So first, we will set up the instrument on the tripod. तो मैं आपको फिगर में दिखाता हूँ। This is the operating procedure of throat session. First, you have to center the throat session, then label, then open a job, then session setup, then data collection, data transfer, and processing. So set up the throat session. First, open the close all three legs and open up to your chest height. Then close the screw, all three screw. Here is the screw. You can close this screw, all three screw, and then spread over the control point. And this small drum will be clear your parallax of your circle and dot. Laser is going down and one light will be seen on that plus point. So in that laser case, you have to level with the help of the leg and center the laser. Optical plummet also you have to level with the leg and see the center of your uh, control point. But in optical plummet, accuracy will be 0.2 mm. Laser plummet is your dot is 2 mm. So you will achieve only 2 mm accuracy. Here you will achieve 0.2 mm accuracy. So optical plummet is always better than laser plummet. For rough work, you can use the laser plummet, but for accuracy work, always use the optical plummet. All manufacturer will have optical plummet also, laser plummet also. But it is up to you that which type of optical plummet you want to use in your instrument. Battery is the optical plummet. So this from this when you have seen the optical plummet center of your pillar, then with the help of these legs up and down, you can center the circular bubble. Circular bubble is the TS will be available. With the help of this leg, you can center the circular bubble. Because if you are doing the centering through the optical plummet with the help of leg and screw, so level will not correct. If you level with those screw, your center will be out. If you are doing the center with the foot screw, your level will be out. But when you have done the even with the screw, you have done the centering and level is out. So with the help of leg, if you level it, your centering will be not out because you have done the centering leveling from the this leg, centering from the foot screw, but leveling with this leg, your centering will be not out, hardly 1 or 2 mm 5 mm out will be there. Then you have to because of bubble circular bubble you have done it. Now switch on the instrument and bring the electronic bubble. There are two tubes. One is this tube, second is this tube. This tube work for AB and this tube work for C only. So you have to label this tube, and with the C you have to label this. So you have to measure this A. You can assume this is your A, this is C. This is your A, this is C. This is your AB. Opposite we always see. And two can be made AB. But label AB or implement your control. After labeling, for observation. This is the basic key. Key means instant you want to give some command like a hotkey. So if you press the star button, your electronic bubble is out. You can see battery status, see everything you can see with the star button. Next is the light button. Light button means it is illumination the keypad. In the night if you want to measure, but keypad doesn't have the light, so you are not able to see what is the number. You want to feed the number coordinate, so should see the numbers. So illumination is the keypad. And if you press for long, laser pointer will also on. Next is the power button. You press the power button on and off. This is the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like this. This is the A B C D E F G H I J K L M N O means all key will have three characters. If you want to type O, then press 5 to 3 times. सर कोई साउंड आ रही है? किसी का साउंड आ रहा है, स्पीकर ऑन है क्या? म्यूट कर लीजिए, या कोई क्वेश्चन है तो बताइए. एनी क्वेश्चन? Okay. So this is the display unit. You can see the display. It is a DOS. If it is a DOS, it will show the DOS. If it is a window based, then touch can be work. This is the 0 to 9 key, A to Z value. This is a tab button, going program to another program, backspace, deleting the back, space, giving a space, function, different function. And these are the sensor and microphones, sound. This is the prism to non-prism mode. This is a shift alpha to numeric, or small to capital, the enter button. And this is the input, alpha input. This is the program button. And this is the up, down, left, right arrows. So these are the keys of your basic screen of the tool system. Standard operating, first we have to fix the north. In the toll session, minimum 2 point is required to start the project, and both should be visual to each other. Why it is required? To fix the north, to get the north. If you have done a DPR, in which north you have done a DPR. Now for coming for construction, you have to follow the same north line of your DPR, because design is as per your DPR. So you should follow that north only. To fix up the north line, we have either observed the sun and pole star, or magnetic north, or GPS coordinate. From GPS coordinate we get the north, or arbitrary north line. These four function, by four function you can fix the north. Then with respect to that north, you will be in the first quadrant, second, third, and fourth. For job creation, first switch off the instrument. Whenever you switch on the instrument, automatically first electronic bubble will be displayed. You have to label it. Then it will show you the basic screen. This is the horizontal angle. This is the vertical angle, and the slope distance, horizontal distance, vertical distance. So it is up to you. You want to see horizontal distance, yeah, you want to see slope distance, or you want to see vertical distance. You can change over here. Then here you can see horizontal angle, horizontal distance, vertical distance, and slope distance. Raw data is these two, and slope distance three raw data. These are two calculated. Then northing, easting, Z. This is also calculated. Horizontal distance is calculated. This is the horizontal angle, vertical angle. So these are the three screen. One is the slope distance, horizontal angle, vertical angle. Second is slope distance, horizontal distance, vertical distance. And third is the graphic, northing, easting, and jet. So you can occupy the station, backside, and start data collection. These are the DOS based command. But if you have a window base, you can run the software, window software. So we have run the magnet field software. When you run this magnet field software, he will ask job name. So you can give a job name. Like I'll just run the software. This software is seen to everyone. डिस्प्ले में आ रहा है स्क्रीन.
Yes, sir. Yes, sir.
This is the field software. In the all total will have this type of software. It may be a different brand. So name may be little bit changed. Not like exchange here. Exchange somewhere communicate. So little bit name change, but almost same function will be there. And for normal topography, we have to do first open a job. When click this icon job, create topo. I say click optical control point coordinate system is grid. Then you have to select here grid coordinate system. Then you have to select this projection and datum. If your control point is ground coordinate, then you have to select none here. You want in meter or feet? You can change over here. Meter, feet, distance accuracy. You want millimeter or fraction of millimeter. If you want fraction of millimeter, you select 1, 2, 3, 4. After meter, it is point 1 is decimeter, point 1 and 2 means centimeter, 1, 2, 3 means millimeter, 1, 2, 3, 4 means fraction of millimeter. So it is up to you that you want if you want 1 second, then just select in the northeast. If you want 4 digit fraction of millimeter, so you can change over here. Can show latitude also. So if you want the latitude kilometers, so it show degree, minute, in part of second. Or you want precision, after it show 5 figure of seconds. Same height up to 3 means up to millimeter. You want fraction of millimeter, you can select the fraction. So coordinate give you on, then you can select here. Main audio alarm, audience alarm, RTCM coordinate system, okay, control, power on, memory. These are the normal power alarm and grid ground warning. Now you can click here, yes. So your all setting has been done. IAHE 13102022. You are ready to, it will be stored in this file only. IHE 13102022. All file will be, all data will be saved in this job only. So first thing you have done, job open. If any configuration is required, you can go to the configuration, but I have done already configuration in the opening job only. So no configuration is required. Next option is your setup. When you want to do the setup, station setup, you go to the setup. Now this is okay, connected to optical. When we go to the setup, there are these function to set the total station on the ground. One is the benchmark, reference line, reference direction, set up by grid line, backside adjustment, localization, remote control. In the field, we use these three functions. Rest all are similar to these. First is the backside. Backside means you should have two control points and equal to each other. In so that is called backside. Directly you are setting up instrument on top of the. So in that case, instrument will ask you where you kept the instrument, what is the height of instrument, and where is your backside, what is the height of backside. Then you press the measure button. It will measure and set his angle. Now he is ready for observation. So in this case, instrument should be on control point, prism should be on control point. But like we have done a DPR, and in our project only two control points are available when we are going for construction. As per DPR, only two control points is available on the ground, but both control point not visible to each other. Means when they have made the DPR, that time it is visible to each other. Now somebody has constructed house in between. So now it is visible to each other. But we want to construct as per this coordinate system, we want to construct the road. So what we will do? We can do the resection method. Resection method means we will kept one prism in this control point, second prism on this control point, and set up the instrument at unknown point from where we can see this CP1 and CP2. You can place the TS at such place from where you can see the CP1 also and CP2 also. In that case, you measure this CP1 because this unknown point, from unknown point you are able to see this CP1. So torsion will measure this distance. After that, measure the second CP3 because it is visible to this TS. So now what happened? He has measured this distance also. And CP2 to CP3, because they have coordinate of these 2 points, he has calculated this distance. Now, and he has measured this angle also. Now in this triangle, he has measured this distance, calculate this distance, and measure this angle. Four things are known in this triangle. All three distance and one angle. So it will calculate A upon sine A, B upon sine B, C upon sine C. So it will calculate this angle, B angle also. Then C angle also. A upon B, C upon A upon sine A, B upon sine B, C upon sine C. He has calculated this C angle and B angle. Now this angle is known. This bearing is known. You can add this angle, he will get this bearing. This bearing is known. He can subtract this angle, he will get this bearing. Now you have this two bearing and distance. From this point also bearing and distance, this point from also bearing and distance. He will calculate this coordinate. Yeah, some instrument will say free station. Company will say resection. In the resection or free station, both points are known, but not now we have these three cores point. We can mark the center line. This is my center line, or we can बैक साइड रिसेक्शन का कोई क्वेश्चन है? Okay, no issue. Then we go to the benchmark. Next is the benchmark. Suppose we know the RL of this benchmark, but we don't have the XYZ of this point. So first set up the XYZ coordinate and shift this benchmark value to your instrument where you have kept. Just give the RL of this value and height of prism. It will, from this RL, measure this vertical angle and slope distance. It will calculate the horizontal distance, this vertical height. So vertical height difference minus from this height, it will minus this height. So it will get the height of prism center. From this, it will subtract the height of instrument. You will get control point value. From this benchmark, you can directly shift to your instrument RL. Like this is my benchmark of benchmark number 5, and this value is 500 meter. Okay, we want to shift this benchmark. We have started the project from 100 for example 100, but later stage we get this benchmark value is 230 meter. So but when we have collected from here, this value is 106 meter. Now because we have assumed 100, with respect to this we have surveyed, and when we have collected this benchmark, this value is coming 106. But we want all coordinates should have RL with respect to this 230. So we can go to this benchmark setup and set up the prism over here, height of prism. He will measure this height, and because from this RL 230, he will add 1.5 meter height of prism. So the RL of prism will become 131.5. From here to the TS, he will get the vertical difference. Like vertical difference is 1 meter. So it will show you 230.5 meter is the horizon RL of TS. Now from here, if I subtract 1.2 height of instrument, so from here, if I subtract 100.2 meter, so the RL of control point will become 129.3 meter. So now this control point is 129.3 meter. Now instrument will ask, calculate of data in the file. जो पहले you have collected all control points, all topography in this field. You want to adjust with respect to this 230. If you give a command yes, the total session will calculate all vertical Z value of all control point with respect to this 230. Now you have map with respect to this 230 RL. Now clear, sir? So this way we have done backside, resection and benchmark. These three functions are more useful on the ground. Same way, a reference line act as a resection because one prism here, one prism here, this is the direction of line, it will resect it. Same way, reference and direction, same resection method is done. Here and direction you have given, it will collect the set your instrument. Same way, grid, you have a grid coordinate with respect to this grid coordinate. Grid, you it will set up your instrument. Backside adjust, you want to adjust the backside, you can adjust. Localization means it is in the GPS, you want to localize, like GPS coordinate is coming in the 6 character, 7 character, you want in the thousand system, you can localize to the thousand system. Remote control means motorized instrument if you are using, you can do with the remote, instrument will move automatically. So these are the station setup function. When you have complete the station setup, then go to the survey. Survey means there are function of doing the survey. One is the topo. Topo means you have to collecting the points. When you click on topo, it will come point number, uh, northing, easting, elevation, raw data, everything is coming, and code. So you can collect that. Next is the auto topo. Auto topo is the in the motorized toll station. Like you have given command auto topo, there are two functions in the auto topo. One is the distance, one is the time. So if you want to record with the help of motorized procession, every 5 meter cross section you want to record. So give a command auto topo 5 meter interval. When you give a command auto topo 5 meter interval, it will collect GL, ground level. Then you move 5 meter, automatically it will record. Then from here, if you move 5 meter, automatically record. From here, you move 5 meter, it will record. Then from here, you are shifted to the next cross section 5 meter, it will record. Then from last point, next 5 meter, record. From last point, next 5 meter, it will record. So it will record automatically every 5 meter, and you will get the coordinate of every the toll station will be free. ये स्क्रीन पे
Yes, sir.
ओके ये देखिए जो दिस इन मोटराइज्ड रोड सेशन so toll station will be kept automatically with the prism because instrument is following him. It is prism always from this is the if it is moving up and means when he is rotating like this the prism is here. If it is rotating, going down, going left, going up, going like in between tree is coming, but also he is falling because he know the man is moving with the 10 km speed. So in between, if tree is coming, also he is directly following to the prism man. So same way when we are doing the topography, auto topo, man is moving, he will follow the prism. But we have given a command that every 5 meter he should record in the memory. So the man from one place to another place moving, when 5 meter is over, because coordinate continue is measuring, when 5 meter is there, he will record in the memory. Then distance will 5 meter, it will record. 5 meter record, 5 meter record, or 2 meter or 1 meter, whatever distance difference you have given. Command is given 1 meter, 2 meter, 5 meter. On that spacing, he will record automatically on the topo, auto topo. Cross section, while doing cross section, he will take the cross section, next cross section, next cross section. Find station, any station is required to find, you can search. Tape dimension, like you have measure with the prism, but the prism man is not able to reach that place where you want the coordinate because it is not visible, that not visible to the total system. Some tree is there, we want the coordinate behind this tree, behind this pen drive we want coordinate. But if I'll keep the prism here, total system is not able to see this prism behind this. So what we'll do, we can measure left side and then give a dimension by the tape that right side 0.8 meter point is there. So torsion will automatically measure up to that point, but automatically rotate to zero point 0.8 meter left because you have given a command 0.8 meter left side. So it will rotate to 0.8 left and save in the memory. Surface topo, you have done a surfacing. With respect to that surface, it will automatically collect the topo. Missing line means you have a missing lines, like we have a building, but we normally measuring from this building, whatever we are constructing or making a bridge, we want the length between two pillar. But here what is doing, measuring from this torsion one pillar, so we are measuring this distance from torsion to second pillar, we are measuring this distance. Either we record this pillar coordinate, then go to the calculate and get the distance between two pillar. One option is this. Second option, if we don't want to record in the memory data, then we are, but we want the distance between these two pillar, then what we will do, we can go to the missing line, we measure this, then measure this. Instrument will not show this distance and this distance, it will show from this pillar to this pillar, directly show the distance. From next this distance to next pillar to next pillar, like that, missing line. Monitoring means we can do that also. monitoring with the help of toll station. When breeze is there or pile testing will be there, in that case, what we required every, like pile testing is there. When we are keeping this much load, how much it is going down. When we are keeping this much load, how much it is going down. For that purpose, we will keep 5 to 6 mini prism permanently fixed on this platform. Then set up the instrument. Instrument just search this 5 point, measure 1 point, measure 2 point, measure 3, 5, 6, 7, and record in the memory. Like from the 100, these are the RL now. After half an hour, what will be the RL? The instrument will automatically switch on after half an hour because it is motorized, and it will collect center of the, because it will automatically center the prism. This is whatever video I have shown you, it will automatically collect the center of prism. So when it sight the center of the prism, because maybe after half an hour it is going 10 mm down. So prism center will go also 10 mm down. So he will select this prism center, measure and record in the memory. Second, record in the memory. Likewise, every half an hour detail you have all 6 prism. So you can monitor, okay, 10 o'clock this is the position, 10:30 this is the position, 11 o'clock this position, 11:30 this position. You can monitor. Or if it is 24 hour, it means it is not settling, everything is okay. So this way you can monitor. Or dam monitoring, or means any collapse is monitoring, collapse site is there, you can monitor that site also. Or if you are constructing a like tunnel, so building should be monitored on top of that, so that can also be monitored with the toll station. Monitoring is two type. One is the manual, second is the automatic. Automatic means you should have connect with the net. Toll station will directly give information to your computer. Like if I'm making a tunnel, some buildings on top of that, we have fixed the TS away from the your area, and then in your area, whatever building is there, you have fixed 3 4, minimum 3 to 4 prism on building. He will monitor those building and 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 show the graph how it's now building. If it is out by 5 mm or 4 mm, you have given a threshold that 4 mm message should go to the surveyor that this point is out by 4 mm, going down 4 mm. So he will inform to the executive team that work should be stopped, building is going 4 mm down. Second threshold is 5 mm, so survey manager should go. In that case, in 4 mm only surveyor should get message and email. In 5 mm, surveyor also get message and survey manager will also get the SMS and mail also. Then 6 mm project manager will get information that this building is going down. So first only survey manager, third case surveyor manager and project manager, fourth case surveyor manager, project manager and project director. So this wise you can just give a threshold that whom to inform, like every time not to disturb the ED, but first time instrument will inform to the only surveyor. So this type you can say online monitoring. Online monitoring means online data is transmitting to your office. On the thing is going wrong, it will inform to your different person as per their rank, as per their requirement. Manager, 6 to project director, 7 to project 7 project director. So this way, if you have configured, message will go to the respective person only, not to all. Next is the set collection. In the set collection total session function, set of collection means you have you want high accuracy traverse. In that case, you have to cite phase 1, then cite phase 2, back side, forward side, phase 1, phase 2. So it will take mean. So you have to write mean, then calculate, then record, feed again data. But in this total session, you have a set of collection. In set of collection, you have to cite, back side, forward side. If it is a motorized, automatically it will rotate back, forward, back, forward. Like this, it will do the 3 set. 3 set means 6 backside reading, 6 forward side reading. Mean of these 6 reading, he will calculate and record in the memory, that is called set of collection. Means many set it will collect and record in the memory and finalize the coordinate of next point. So in the traverse method, we normally do this set of collection. Next is image scan. If you have an image, you can scan that image from the ground, or you have a coordinate like left top and right bottom. You define these two coordinates and ask them to scan every 1 meter. So he will collect automatically. Topography will collect from 0, 1, 2, 3, 4, 1 meter he will collect, then go down like it is a hillock. This is a hillock. You want to scan this area. That case, you define this left corner, top left corner, and right bottom corner. Now he has a grid. From here, you want the top of this area, every 1 meter. So it will collect 1 meter, 1 meter, 1 meter, 1 meter, 1 meter, 1 meter, 1 meter. Then go down 1 meter, 1 meter, 1 meter, 1 meter, up to here. Then go down 1 meter, 1 meter. Because it is a reflectless mode, directly hit the hill and give you the coordinate like that. So in the scan function, you will get the coordinate every 1 meter. But this is a small scanner in the total. In this is because it is a motorized, it's moving automatically and collecting. But one more scanner is coming. In that case, if you scan this area in total session, you will scan one point per second. Means per second you will get 1 point only, but in the scanner 1,20,000 points per second it will scan. But some scan function is there in the processor, so you can collect the topo. While collecting the topo, okay, like if I'm doing the topo, okay, tomorrow we'll do some practical. That time I will connect the instrument directly and show you how to collect. So in the I'll just go through first PPT. So in the job, we have to open the job, give the name, job name, then training, scene setup. We have to go to the backside, then backside point number, height of instrument, sorry, station occupy. Occupy means instrument number, instrument height. If it is a grid coordinate, then you have to select the scale. If it is a ground coordinate of control point, then give a scale factor 1. Then backside point number and backside prism height. You have to feed this data, means instrument number, instrument height. If it is a grid coordinate, then scale factor. If it is a ground coordinate, then scale 1, backside point, and prism height. So here we have put point number 1 for instrument. Height of instrument is 1.5, ground coordinate scale factor 1. backside is azimuth. We know the bearing only, not knowing the coordinate, and height of prism is 1. Then if it is, or point number 2, you can feed the bearing or point number 2. If you don't have the point number of backside, you have a bearing, then give a 0 0. Otherwise, if you have a coordinate system of backside point, then feed point number 2. When you have given for feeding point, you can directly feed by alphanumeric, or you can select from the list, or you can select from the map. Same way backside, you can feed from the keyboard, you can select from the map or select from the list. Here is the list, and here is the map. Is the map is the list. So you have given point number 1, height of instrument is 1.5, ground coordinate scale 1. Point number 2, height of target is 0. Then you have given command next. When you have given command next, you will say occupy point not found. Means where we have kept the instrument, that point is not found in this job. It is a new job, so it is not available in this job. So what we have to do, we have to feed the, now he is asking, we have given a command close, then he have asking northing, easting and elevation. So we can feed the northing 1000, easting 1000 and elevation 100. We have assumed this is my value of your control point number 1, or somebody has given point number 1 coordinate is northing 1000, easting 1000 and elevation is 100. Then when you are storing in the memory, then he is asking this stn1 code is coming first time. You want to store in which layer? You can click on this dot dot. You can add a layer, give a new layer name, or layer color, and store in the memory. Now this stn1 code is stored in the memory. This stn1 code is stored in the memory and is ready for, because you have given layer 0, every and plus chain will be there. Now after this he is saying backside point not found. Point number 2 is also not found. So you have to feed the point number 2 code stn1 or stn2, northing, easting and elevation. When you have feed it like northing 1010, easting 1000, elevation 100. Now he's asking backside point 1 code. So whatever code, international code are available in the list, but you can feed your own also. So when you have given BS1, now it is a point, line, area, whatever this, you can feed it. Now instrument is ready for setup backside. He is saying my occupy point is 1, height of instrument is 1.5, backside is 0.2, height of target is 1 meter, bearing is 0 because we have given 1000, and point number 2 we have given 1010 northing. It means 10 meter towards north. So bearing will be 0 0. So when you given a command set, he set the your instrument, and here is your instrument, here is your backside. Setup, measure and data. You have measured this set, then you are going to data you have seen it's matching. Then from the map you can see over the map, this is my station point, this is my backside point. Now it is ready for observation. So you have done the sense setup complete. Come back to the main menu. From main menu, station setup complete by non-coordinate. Now one can to detail topo survey, layout and traverse. After stage setup is complete, now you can do the topography of the area, detailed topography of the area. Prism man move one place to another place. You just measure and give a command record. Is a traverse topography. When you go to the topo, means here go to the survey go to the topo. When click on topo, here it is asking point number, code, height of reflector. HR means height of reflector, height of prism, height of reflector. So you have given my boundary wall and height of prism is 1 meter. Here is a command. This, if you click on this procession, it will measure and show you the reading only. And here is a measure and record. Floppy is also there. Means it will measure and record for you in the memory. So when you have given a command boundary wall BW, then it will ask, you have given command measure only. So here and given measure, and if you have given measure and record, then it will ask what is the height of prism, 1 meter. Then it will show you the coordinate. Okay, this is the coordinate of next point, whatever you have measured. Then he is asking in which layer you want. So if you want to change the layer, you can feed the layer name, because by code it is recording in the layer. Like it is a ground level, GL, you have given a code, so your layer will be ground level. So it will record in the ground level every time. So if you want, you can change the image also and record in the memory. All image, any image of any photo of that point is there, you can record. So you have given point number, layer style, image, and then it is ready to record, save in the memory. Next point is ready. Now point number 5 is ready. When you give a command yes, save in the memory, so this point will be saved in the memory. Next point is ready for measurement. When you press this measure and record, it will record in the memory. So this way you can, this is only measure, this is measure and record. Floppy is extra, measure and record. This way you have recorded up to 8 point, means 7 point you have recorded. 1, 2 you have fed it, 3, 4, 5, 6, 7 you have recorded in this job. Now you want the map, view map. This is the, go to the, from the screen, you go to the map directly. Map means now you have see 1 and 2 is the control point. 3 you have not recorded, 4, 5, 6 and 7. So these are the 4 number boundary wall, 5 number boundary wall, 6 number boundary wall, 7 number boundary wall. So you have selected all, it's showing everything. Code, point number and elevation on the display. Here you can see, if you want to, if you don't want the code, then untick this. If you don't want the elevation, then untick this. So it will show you the point name only. So this way, if you want to join the line of this points, then go to the edit. Okay. If you want to create a point list, then go to the edit, then point. You will have a point like 1, 2, 4, 5, 6, 7. Now you can add this list 1, 2, 3, 4, 5. It will make a line for you. So there are many functions, like you can give command joining line by all. All means 1, 2, 3, 1, 2, 4, 5, 6, 7, like that it will join. You can give by range. Here on the bottom right side, you see by range. If you want to join the line by range, like 3, now 4, 5, 6, 7. So it will join 4 to 5, 5 to 6, 6 to 7. Or next command is by code. If you have given a command by code like boundary wall BW, so give a command by code BW, it will join 4 to 5, 5 to 6, 6 to 7. So this is very useful. Like we have collected huge topography and we want to join line only, center line only, center line of the road. So we have given a code center line CL. of that points. Whatever points we are collecting on the ground, like this is my existing road, we have collected center line, then road right, road left, RR, RL, uh, GL, like that we have collected the cross section. Now every cross section has one CL, one RR, one RL, rest is the GL. Okay. Now we want to make a drawing in the instrument itself. So we can give a command join line by code, by this code. When we give a join line by code, then what happen? He will ask them to select the code. We have selected code center line. So it will join nearest point of center line incremental number. Means like first center line point number is 3. Second center line point is 9. Third center line point is 15. So it will join 3 to 9, 9 to 15, 15 to 27, 27 to 31, 31 to 42. So this way, whatever the center line code is there, point number, he will join that point directly. 1 to first 3, then 9, then 15, then 27. This way, continue center line. Then you have given a command RR. So it will join the RR. Then you have given a command to left, RL. So left. So it means within a one command, even your road is around 50 kilometer, it will join a line CL up to 50 kilometer. Then road right up to 50 kilometer. Then road left up to 50 kilometer. Means within a second you have joined 50 kilometer road stretch. If you have given a proper coding, proper layering, so your drawing will be very fast on the screen itself, and then you can export this data to the DWG format, AutoCAD format, and you can use those data for your design purpose. So these are the points. Line work, I have explained you how to join the line by all means all points, range means range. Like here we have given range 4 dash 8 comma 4. If I given this 4 dash means 4, 5, 6, 7 and 8. In between whatever point he will join to all. 4 to next point is 5, 6, 7, 8, 9. But from 8 we have given comma 4. It means it will close 5, 6, 7, 8, and then again it will close to the 4. So we have given a command 4, 5, 6, 7. 8 is not there, but next number is 7 in the memory. Then 7 to 4 he will join automatically. So this will become one line complete. We have given a command 4 dash 8 comma 4. 4 is not there, 8 is not there. So next incremental is 7. He has joined 6 to 7, 7 to 4. This is complete. And this is the line. It's showing this is the horizontal and this is the vertical diagram, elevation. So this with the here you can see in this map, elevation is also available on the map. But when you have elevation, code, point number, many data, so it is not visible in the small screen. This hodgepodge is there. So you can remove with the uh, this message that we don't want the RL to be seen. So RL is removed. Click over here and untick the RL. RL will be not seen. If you click here, click the code will be not seen. This way you can collect the topography. You can join the line data on the field itself. Collection of data in the field and joining the line in the field itself. Because sometime what happen, you have given a code building. Building 1, building 1, building 1. Next also, by mistake, you have given code building 1, building 1, building 1. So what happened? This is one building, second building, third building. But by mistake, these four corner is also BLD1, 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 BLD1. This four corner also you are given command BLD1, 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 BLD1. So the and in between is a 15 kilometer gap, 15-meter gap, and our road requirement is 7 meter. So, but what happened? The AutoCAD person has joined building one from this building one to this building one also. This building one, this building, this building, this building, like that he has made a building. So there is a no gap in between 15 meter. So designer will say, okay, it is a huge building. We can design from somewhere else. So in this case, this is the lack of data collected by the surveyor and the AutoCAD person because he has joined this way. But if the surveyor has joined this drawing in the field itself, so he has seen, okay, this is my building, this is the second building. So if it is a code building one, he will join this point. Point number by 4, 5, 6, 7, and comma 4. So it will join 4 to 5, 5 to 6, 6 to 7, 7 to 4. So in this way, this is one different building. This is the 8, 9, 10, 11. He will join this way. So in the instrument itself, he will join and directly export to the DWG. So designer can understand, okay, this is a different building, this is a different building. So we can design 7 meter road in between. So this is the way, good way to measure itself on the ground, make the drawing itself on the field itself. So easily you can come to the office and nothing will be error in your drawing. Second, for example, you have collected only 3 points on the ground. Fourth point you have forget it. You are thinking we have collected. But when you see on the drawing, you can see, okay, this point is not collected. From there itself, you can collect and record in the memory. So seeing the map is very useful because surveyor can make the drawing in the field itself as well as if any data is left, he can collect there itself. Otherwise, he can understand, okay, when he is downloading data, transferring to the instrument computer, then AutoCAD person is saying this point you have not collected, then he will go again to the field, collect again and come back. So there will be huge work will be there. But if you have a drawing function, you can directly see on the drawing, okay, this point is left, you can collect there itself. So time is saving. Layer management, different layer you can make as per your requirement, like different color style, line style. You can give image, you can get the image on background. Like in the 12th session you have done that topography, designer has designed. Now you mark the center line on the ground, you can stack out the center line on the ground. In that case, if you have a background map where it is coming, in which land he is coming. So if you have a background, whatever drawing you are made, that same drawing is back on your screen. So whenever you are marking that point, you can understand, okay, this is correct, going correct. My center line is going correct way. So in this function, instrument has the background image also. So your background image may be TIFF file, JPEG file, BMP file, whatever image is there, he can load to your memory. And if it is AutoCAD drawing also, it can come AutoCAD drawing also. You can see one AutoCAD drawing. You can give a path, 3 element imported, map you want to see on the map. This is the drawing whatever drawing you have, this is my drawing. If you want to mark this drawing on the ground, on the background you have a drawing, you can just set up the instrument as per the coordinate system, same coordinate system, then give a command stack point number 3. Instrument will guide you and demark the point on the ground. Contour and volume. With the help of total session, we can make a contour, make a volume calculation, and tin file, DTM file, data terrain model also. We can make a data terrain model also. So when we are going for this, first we will go to the calculate. Then from calculate, we go to the, this is the, when click on calculate, go to the surface. Click on surface, these three function will come: create, volume, and contour. First of all, we have a n number of point in topography: GL, 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 building corner, electrical pole, telephone line, main hole, whatever you have collected on the ground, everything is recorded in your memory. Now this job, IHE 13102022, suppose have 5000 points. All points have different code. So we can create a tin file. Tin file means nearest point he will join the triangulation method. So whatever RL of point number 7, whatever RL of point number 8, whatever RL of point number 9, he will join nearby and manipulate. Like 7 RL is 1 meter, 8 RL is 2 meter, 9 RL is 3 meter. It means 1, 2 and 3. There are different of 1 meter between these 3 points. So he will join point number 7 to 9, 7 to 8, 8 to 7. It will interpolate in between. Like it is RL is 1 meter, his RL is 3 meter. So it is 2 meter RL difference. Here 1 meter RL difference. Here 1 meter RL difference. So he will make a interpolate in between and make a contour. If you want a 0.1 meter contour, he will just made you for a 20 contour in between these 2 meter, 10 contour in between this 1 meter difference. So he will make a contour for you. So first of all, we have to make a DTM, data terrain model. Data terrain model have, because we have learned that total session will collect coordinate x, y, and z. So DTM will have data terrain. Data terrain means whatever x, y is the distance between 2 points plus height difference. So what is the terrain? How is terrain is there? That because of these data, somewhere data is going down, up, down. So my terrain is like this. So our contour will be like this. So we'll go to that. First we have to create a tin file. For creating the tin file, we have to go to the create. Then he is asking point. Select the point. In which point you want terrain. Like I have many points. I don't want to consider tree, the TR code in our triangulation file, DTM file. Because tree we have collected somewhere in reflectors mode, we have collected 1 meter up, 2 meter up, I don't know. So RL is not correct. So in that case, we have to select point by code. So when we have select point, like all select, so he will select all and make a tin file for you. But if I select by code, here we can select by code. Okay, I have not shown you the code, but if you select like code BW, 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 only BW, BW point will be selected. If you are selected by code, only boundary wall will be selected, not station point. Station point is not selected. So it is depend upon you. You want all point or you want to leave some point. So when you give a code command, all code will be come on the screen. Just you can select all will be selected, but you can go one by one. You don't want the tr code in the triangulation file, then untick the tr. If you don't want the convert point to be added in the dtm file, untick the convert. So whatever you have unticked, that point will be not shown in your triangulation file. Like here you can see these 2 points are not shown in your triangulation file because we have selected code BW, boundary wall. So here I have selected only boundary wall. Then you can say save. It will save in the memory and it will show you the total as is 5, number of triangle is 2 because 1 and 2 triangle, and number of point is 4, omitted point 2, 2 point we have not taken. So all detail he will show you. Then tin file is made. Now we have different tin file. Like when we have started the work, we have done a topography that is called original ground level, OGL. OGL means original ground layer. We have collected the original ground layer first, then we have done the earthwork. So we can give a command final level, FGL, OGL, FGL. We have collected two code, then we make a tin file with the OGL separate, code OGL separate, and code FGL separate. Here we want the quantity, how much quantity you have filled. Then you define this is my original, this is my final level, this much quantity is there. So it will give you. But first we have to create a tin file. After tin file, we make a contour. When we are going, this is my tin file, triangular new tin file. This is my tin file. Okay. After that, I'll go to the contour. When I'll go to the contour, so I have to select the tin file. In which tin file we want contour? OGL, FGL, yeah, new tin, whatever you have given the name of tin file. So like OGL you have given. So this is the original ground layer, for example. I have given new tin, but for example, it is the original ground layer. So he has selected this original line. Then he has given command that because elevation difference is very less, so we have given 5 contour to be made. So when we have given a command 5 then he say okay, number of contour 326 he has made, and these are the contour of new tin file. Same way, OGL tin file, FGL tin file, both can be made contour of both layer. Both layer means OGL layer, FGL layer. We have to make both layer separate tin file. So we make the separate contour. Whatever contour, like first you have given a command 0.05 then you have given a command 50 So he has made the 50 contour. Now you want the volume. When you want the volume, then you can go to the calculate surface volume. In that case, you have to define original surface and design surface. Original surface is your OGL surface. You have to select from this OGL and then FGL, final ground level. And then give a command calculate. It will show you the quantity, how much you have filled in this area. So total quantity it will show here. So this function is very useful in the field. Sometimes somebody will ask how much aggregate we have, 10 mm, 20 mm stock. So you can do the OGL just around the stock, that is your ground level tin file. Then collect the top point of your stock, merge the OGL and stock all point. So you have now two tin file. One is the OGL tin file, second is the OGL plus stock all. Because you have collected the OGL, so it will merge. Now you have one layer is this tin file, second layer is this tin file. Now you will calculate the quantity of what quantity you have, 10 mm and 20 mm aggregate, whatever the aggregate is there. This way you can calculate the volume. So today maybe up to here, any question? आज के लेक्चर में कोई क्वेश्चन है आपको? Please ask. There are 2-3 minutes. You can ask anything. Even I can be long if you have any question.
Hello, sir.
हाँ जी.
Hey, can you help us? What does mean by 1 ppm, 2 mm plus 1 ppm?
1 part per million.
Part per million. Second, what is difference between control point and benchmark?
Control point.
And benchmark.
Okay, control point will have value of X, Y, and Z. Benchmark maybe have only vertical Z value only.
Okay, okay. Thank you, sir. Thank you.
This is 2 mm plus 2 ppm. Means 2 mm is the constant value. It will have in all point. It may be a point will be 200 meter, 300 meter, 500 meter, 1 kilometer, 2 kilometer. This value will be remain 2 mm. But this value will be changed. 1 ppm means 1 kilometer, 1 mm. If somebody say this is my accuracy 2 mm plus 1 ppm, it means 2 mm is the constant and 1 ppm is 1 kilometer. If you distance measure, it will be error of 3 mm. If somebody say my instrument is 2 ppm, it means in 1 kilometer distance 4 mm error will be there. So 1 ppm 3 mm 1 kilometer distance, 2 ppm is 4 mm per kilometer. Clear? Hello?
Yes, clear, sir. Thank you.
Okay, thank you. Anything? Thank you all of you for listening this lecture, and we will tomorrow again come at 10 o'clock. So tomorrow also 10 to 1 our lecture will be there. If you have any question today lecture also, you can ask tomorrow also, no issue.
Thank you. Thank you, sir.
Thank you, sir.
Thank you. Good afternoon all of you.
Thank you, sir.
Thank you, sir.